Hi guys, welcome back to Math with OG. In this video, we'll be looking at the intersection of sets. Now, what does it mean for sets to intersect? So let's look at the definition from what we have on the board. So assuming we have A and B to be two given sets, the intersection of A and B, denoted with this symbol A intersect B, is the set of elements which belong to both A and B. So the set that you can find in both A and B is the intersection of set A and B. For example, you have a set A. For example, you have a set A to be equal to 1, 5, and 6, and you have a set B to be equal to 2, 4, and let's say 6. 1, 5, 6 is set A, set B is 2, 4, 6. What is the intersection of A and B? Is the element you can find in both A and B, and in this case, the answer should be 6. So this is the answer for A intersection B, what you can find in both A and B. We're still going to look at an example before we round off this class. Now, if we are to denote this definition using our roster method, which we talked about in representation of sets, your rule method rather, which we talked about in representation of sets, A intersect B will be equal to X, such that X is an element of A and X is also an element of B. So what is common to both A and B is what we are looking at. So you can see here that 6 is an element of A and 6 is also an element of B, making 6 the intersection of A and B. But 1 and 5 are not element of A and B, they are just element of just A. 2 and 4 are not element of A and B, they are element of just B. So the answer is just 6. Now, how do you represent intersection using Venn diagram? I believe that in our last two videos we talked about Venn diagram. Either last two video or last video, I can't recall now. We talked about Venn diagram. Now, A intersection B, but to represent it, remember this is universal set represented with a square or a rectangle, while the circular part represents the subset. So this is subset A and this is subset B. The intersection of A and B is where A and B overlap rather. So any member you find here is a member of both sets A and B. Any member you find here is a member of just set A, or is an element of just set A, and any guy you find here is an element of just set B. But what you find in this part here is common to both A and B, and this is the shaded portion for A intersection B. Now over to this side, there's a point here. For a disjoint set, A intersection B is an empty set or a null set. So when you have a disjoint set, that means there's nothing common to them. So if there's nothing common to them, I believe that there should be no common elements to A and B. So if I were to represent that using Venn diagram, this is set A and this is set B. And as you can see, they are disjoint sets. That means they are not overlapping. So because they are not overlapping and there's nothing common to them, A intersection B will just be an empty set. So no part here can be shaded. So this is a diagram for A intersection B. There's nothing to shade here. So for a disjoint set, A intersection B is equals to empty set. Now you can be asking yourself, what are examples of disjoint sets? A set and its complement are disjoint sets. A set A and complement of set A are disjoint sets. You can recall in one of our previous videos, we said that the complement of a set A are the elements you find in a universal set that are not in set A. So anything that you find in universal sets that are not in set A is the complement of set A. That means everything in the complement of set A is not in set A, and everything in set A is not in the complement of set A. Hence, they are disjoint sets. Other examples, you have your odd natural number and your even natural number, they are complements. So you can find 2, 4, 6, 8, 10, 12 down to infinity for your even numbers, and you can find 1, 3, 5, 7 down to infinity for your odd number, making them disjoint sets. Then your rational numbers and irrational numbers are also disjoint sets. No numbers are rational and irrational. That means a number can either be rational or irrational. It can never be both. Now that we've understood what it means to find the intersection of two sets, let's answer these two questions and we'll round it off with intersection of two sets. If set A is given as 1, 2, 3, 6, 9, 18, and set B is given as 1, 2, 3, 4, 6, 8, 12, and 24, find A intersection B. So we have to find the intersection of A and B That means what is common to both A and B. And as you can see, let me use a red marker. As you can see, 1 is common to both A and B. You can find 1 here, you can also find 1 here. Then I think you have 2. There's a 2 here. You have 3, there's a 3 here. You have 6, there's a 6 here. 4 is here, no 4 here. You have 9 here, there's no 9 here. You have 8 here, no 8 here. 12 is here, no 12 here. 18 is here, there's no 18 here. There's 24 here, and there's no 24 here. So what is common to A and B is simply 1, 2, 3, and 6. So I can write somewhere here that A intersect B is equal to 1, 2, 3, 6. And we close it with a curly bracket. So this is A intersection B, 1, 2, 3, and 6. It's as easy as that. Now let's move on to the second question. We're giving set A and set B in rule method. Whenever you are giving questions in rule method and you have to find an operation, it's advisable or it's normal you change to roster method before you go ahead and solve the question. Though we've not done inequality, I believe most of you understand what this symbol means. Then we'll get to inequality, you will understand it better for those of you that don't understand what this symbol means. So this is 1 is less than x is less than 6. So let's go. Set A is equals to x. Set A is equals to x such that 1 is less than x is less than 6. That means x is a number between 1 and 6. Now that information is not enough. They are now telling us that x is a member of natural numbers. X is a member of natural numbers, and natural numbers are positive whole numbers. So we are not going to be looking at 1.2, 1.3, 5.2, 5.4 down to 6. We'll just be looking at the natural numbers between 1 and 6. And that is simply 2, 3, 4, and 5. We won't get to 6 and we won't start from 1 because this is not, x is not greater than or equal to. X is just what's greater than 1. That means 1 is less than x, 1 is not less than or equal to x. So the members of this set is simply 2, 3, 4, and 5. These are the natural numbers between 1 and 6. Similarly, here we are told that set B is equals to y such that 2 is less than y is less than 9. That means natural numbers, they say y is an element of natural numbers. That's the natural numbers between 2 and 9. So we have 3, 4, 5, 6, 7, 8. So I can write here 3, 4, 5, 6, 7, and 8. Now the question, find A intersection B. That means what is common to both A and B? 2 is not common. We have 3 to be common here. We have 4 to be common. And we have 5 to be common. So the answer here should be 3, 4, and 5. The answer here is equal to 3, 4, and 5. So that's the answer to the question. Now to throw more light on Venn diagram, before we round it off, to throw more light on Venn diagram, if you want to represent this very last question on the board, if you want to represent this very last question on the board, this is what we are going to do. Now we just agree that this shaded portion which I just wiped off is the intersection of A and B. Now we'll check what is common to both A and B there. We have 3, 4, and 5. So I can put here, this place is containing 3, it's containing 4, and it's containing 5. So you should know that these are separated. This is not 345. So if not it was big enough, we'll just scatter it inside this particular place. So you have 3, 4, and 5. Now, if that's the case, 3, 4, and 5, what are the elements of set A? Elements of set A are 2, 3, 4, and 5. 3, 4, and 5 is already common to A and B. So what will be here will just be 2. Now, what are elements of set B? 3, 4, 5, 6, 7, 8. 3, 4, 5 is already here, so you are going to have 6 here, 7 here, and you are going to have 8 here. So this is how you present this information on a Venn diagram. So set A is a set containing 2, 3, 4, 5. Set B is a set containing 3, 4, 5, 6, 7, 8. The intersection of A and B is simply 3, 4, 5. Supposing we are given the universal set and we know what is in universal set that is not in A and B, those guys will be found outside there. That means it's neither in set A nor set B, but it's a member of the universal set. So that's how you present elements in Venn diagram. We're still going to look at more scenarios where you see better ways or other ways to represent elements in your Venn diagram. So that's as much as you can take on intersection of sets. Now next video, we'll move on to the next operation or to another operation, union of sets. And thanks for watching. If you enjoyed the video, use the like button, make use of the subscribe button, and also make use of the share button. If there's an error in the calculation or in the explanation, you can point that out in the comment section, and don't hesitate to also leave your questions in the comment section. Thanks for watching once more. See you guys in the next video.